This week, we explore functions in more detail. Before watching this video, ensure that you have understood the basic concepts of functions, how to declare them, and how to call them or invoke them. In this class, we have used a number of functions. Some of them are listed here: input, int, float, range, etc. And we created some functions last week. And one characteristic of functions is that usually, you supply some values when you use those functions, when you call those functions. For example, the input function in Python. This is used to read something from the keyboard, and you supply a string, usually, to input. So you could write input and in parentheses put the string, enter a name. There is an understanding between the programmer like us and the developer of the input function, which is basically the people who developed Python, that this will be displayed on the screen and input will bring me back a text the user enters. So that is the function of the input function. Display the prompt that I supply and give me the text the user enters. Here is another example where I am supplying values to a function. The function in this case is print. I am supplying the value 25 and a string, a message. The understanding here is that 25 will be displayed on the keyboard, and so will a message, that there will be one space between the two, and after printing, the current line will be terminated and a new line will get started on the monitor. And for a third example, I'm using the int function and I'm supplying this text 65. The understanding is that this 65 will be converted to a number that I can use to do arithmetic, like adding or subtracting. The stuff that you pass in parentheses when you call a function is called parameters or arguments. And as I have said before, there is an understanding between the developer of the function and the user of the function as to how these parameters will be used. So these are called parameters or arguments. We can write our own functions that require parameters. For example, here I am creating a function named myFunction, and I'm putting a list of things here, a sequence of identifiers separated by comma. These are placeholders for parameters to be supplied by the user. So I am saying that I have a new function called myFunction, and that when it is called, I require two things to be passed to it, two things to be kind of input to the function, A and B. I'm calling them A and B. And what I am going to do is simply print the values of A and B. I could do more stuff, but I'm just trying to keep things very simple here. When I create a function like this, to call it, of course, I have to type in the name of the function, myFunction, and then in parentheses, the user of this function has to supply two things, one for A and a second one for B. And what I chose to do here was I set X to 2 and put X in the first position here and the string hello in the second position here. So whatever is in X is copied into A. Whatever is in this second position here is copied into B. So A has the value of X. It is a copy. So it contains 2. B contains hello, and the function prints the values of A and B. So I should see 2 and hello on the screen. I have about 3 slides in this presentation that are having a red background to convey the message that you should not be doing certain things when you write functions. One of them is that when you write a function, define my nonsensical function with a parameter A, do not modify the value of A before using it. The user is supplying you, the caller of the function is supplying you with a value for this parameter. And if you don't use it, why are you asking for it? This is either poor design or a mistake. So don't ever code like this. Don't have a parameter and immediately clobber that value. Use that value before you change it, if at all you have to change it. This kind of a function is pure rubbish, because if you're asking for a value, you should be using it. Otherwise, why are you asking for it? And it is a very common mistake. So please remember this. Now, another characteristic of functions is that, or some functions is that, they return some values when called. For example, in this statement, I have the input function called with the prompt enter your name. As you know, this function will prompt the user with the message enter your name. This will be displayed. Then input will wait for the user to type in something, and whatever the user typed in will be stored in name. So this function input returns something to us, something to the caller, a value back to the caller that can be used. Or for another example, you have int input enter a number. Input brings back a text, and int converts that text and gives us a number. So int returns a number. Input returns a piece of text, which int uses, and int gives that number to us. So both of these functions are returning values, are giving us some stuff. The odd function, for a third example, given a character, gives us a number. In contrast, some functions don't return anything. For example, the print function, it prints values, but it doesn't give us anything back. So print prints, in this case, the text, some values, the number 60, 78.3, but doesn't bring back anything to us, unlike input or int or odd or many other functions in Python. We can write our own functions that return values. How do you do that? Here is a function called add. It has 2 parameters, A and B. And what this function does is it adds A and B in this and uses what is called a return statement. This is a statement like or, sorry, like for or while or if, so like any of those, return is something that Python knows. What it does is it ends the current function and returns whatever value that you might have supplied here. Return always ends the current function execution. It goes back to the caller. But you can put a value with the return statement, and this value will go back, will be returned to whoever is calling you, or whoever is calling the function. So for example, this function ends here, obviously, because I have the statement x equals int input, enter a number. So x is some number, let's say 3. Then I'm getting another number from the keyboard. Let's say y is 5. So x is 3, y is 5. Let's just assume. Then I'm calling the function add, and I'm supplying x and y as parameters to add. So x is containing 3. That will be copied into A. A will be 3. Y contains 5. That gets copied into B. So A is 3, B is 5. This statement here adds A and B. 3 plus 5, 8. And it returns, it ends the function add, goes back to the caller with the value 8. So this whole thing evaluates to the number 8. So S would be equal to 8, and I'm printing 8 over here. If a function returns a value, don't ignore it. It is a likely bug. I'm not saying it is always a bug, but it could very well be. So you should check. When you call a function, are you using any return values? If you are not using that return value, why not? What is the reason? Do you have a sound reason for it? For example, if you write something like this, int input, enter a number, we know that we are asking for a number from the user, we get a number, and if we don't use it, there is absolutely no point in doing this. It is wasting everybody's time. Instead of this statement, we should code like this: x equals int input, enter a number. Similarly, in the previous slide here, after calling add, I have something on the left-hand side to store the value. So here is that example of add, returns a plus b. If you call add with x and y, it brings back 8. But then you are not storing that anywhere. You are not using it in any way. You could have at least done something like print and in parentheses put add x comma y. But absolutely none of that stuff is done here. So this is a pointless call. We saw that a function can return values. In fact, it can return multiple values. For example, here, this function get input, when called, you can see there are no parameters here. It doesn't really matter that much, but I just wanted to point that out. We are reading a name into this variable. We are reading the age of somebody into this variable age, and we can return both of those. So you could write return name comma age. So it is not just returning one value, it is returning whatever is in name, that is a piece of text, as well as the number. So when you call get input, it brings back two values. The first one is text name. The second one is a number, age. So on the left-hand side, I have two variables which I called the name and the age, and separate them by comma, and then I put the equal symbol. So this brings back, let's say, Mary and 35. Mary will be stored in the name and 35 will be stored in the age. Now let's get a little more in depth into functions. Functions are pretty independent. If you have variables within a function, you can declare your own variables. You can, they're called local variables. They are not accessible to code from the outside. Variables that are outside of all functions are called global variables. So for example, here, define F4. It has one statement, x equals 1. So x is a variable that is created by this function, F4. It is called a local variable because only F4 knows about x. Consider this function F5. It calls F4, but there is absolutely no way for F5 to access this variable x. X was created when F4 was called, and it is deleted. It is removed from memory when F4 ends. So printing x doesn't make any sense. You can't access this variable which is within F4, which is a local variable of F4. So you can call F5, F5 calls F4, and x is created, set to 1, and destroyed when F4 ends. So all local variables are destroyed when a function ends. In contrast to local variables are global variables. Global variables are variables declared outside of all functions. For example, here, I have a function f1. Then I have a function f2, which has one statement. Then I have a function f3, which has one statement. Look at this variable a. It is not within f1. This is definitely not within f2. It is not within f3. It is outside of all functions. It is aligned with all these d's in the defines. So it is outside of all functions. So is b. It is outside of all functions. A and b are global variables. So let's see how this function or this program works. When Python reads this file, this program, it sees this as the first statement. It creates a global variable called a, sets it to 1. Then it sees f1. It knows that there is a function called f1 and that it has this statement here, but it doesn't do anything else with it. But then it sees this line, which is a call to f1. So f1 is called, it prints in f1, that message should come out, and then it prints the value of a. It has already seen a global variable called a. That is, Python has seen this global variable a, and it has the value 1, so it should print 1 now. Then Python finishes this execution of f1, comes back. Then it sees that there is a function called f2 and that it has one statement, but doesn't do anything with f2. Then it sees this line b equals 2. So it creates a second global variable called b, stores 2 into that, and it sees that the program is calling, or the code is calling f2 here. So f2 gets executed. Here I'm printing in f2, and A. Does Python know of an A? Yes. It has already seen that A. So it prints 1. Then B. Has Python seen a B? Yes, it had seen a B here before calling F2. So this is fine. So it prints 2. And the function ends. Control goes back to where it was called from, and Python continues here. It sees F3. It has one statement. Python keeps this function aside, but then the last statement here is calling a call of F3. So it goes into F3, and it has a print statement. So it prints in F3. Python has seen an A and a B and prints the values in A and B, which are 1 and 2. And the program ends after the call to F3, because when you go back, there is nothing more to be done. So A and B are variables outside of all functions and are called global variables. Let's talk about some details of parameter passing. Here I have a function F6. It has a parameter P, and all it does is setting the value of P to 2. So it doesn't have any great problem solving capability, but this is simply to explain certain concepts. A function of this kind wouldn't really be of any particular use, but we are having it because we just want to illustrate some concepts. So all it does is setting P to 2. The function ends there. We have P equals 4. Let's think about this a little bit. What is P? We said this P here within the function is a local variable. It gets created when you enter the function, and when you call the function and you enter the function, and it is destroyed when you end the function, when you return from the function. So this P that is declared in this line and set to 4 is different from this P. This P is outside of all functions. This is a global variable. Although these two functions are having the same name, they are two different memory locations. This is a global variable P. The other one is a local variable. So this global variable is set to 4. When you call F6 with P, you are sending the value 4, not this variable itself in some sense. We are sending the value, we are copying the value 4 from here to here. So this parameter P is going to be 4. So this is actually not even a local variable. This is really a parameter, but it essentially works like a local variable. So there is no real problem in thinking about it like a local variable. So this P is different from the global variable P. It is local to F6. It gets the value 4, but then it immediately changes that P to 2. This is a copy. This P is a copy of the original P. It initially contained 4 because we passed the original value, but then it was immediately changed to 2, something we shouldn't be really doing in a real function, but this is just to illustrate some concepts, right? So this P has been changed to 2, but that doesn't affect the original. It is like you're having a sheet of paper with some information on it. You photocopy it, give a copy to a friend. If the friend makes changes to the copy, nothing happens to the original. Similarly, This is the original value. It is supplied to F6. F6 gets a copy of the original value. It can change the copy, but nothing happens to the original. So when you print P, after the call to F6 is over, you still get the old value printed. The same rules apply here as before. If you want to modify a global variable, then you need to specify that. We have seen that you can access a global variable from a function, but if you want to modify that global variable, you have to write like this, global P. You're saying that there is a global variable called P, and that you would like that to be changed to 2. So if in this case, the function ends here with P equals 2, this P is a global variable set to 4. I'm calling F6, and I'm saying that I want to modify the global variable P, that I'm using the global variable P. I don't have a local variable, and I don't have a local variable named P, that is, and I'm setting P to 2, meaning that it is the global variable that I am modifying. Now, P equals 2 here within the function actually modifies the global P. So when you come back from F6, print P will actually print the modified value. Now, let's reflect a little bit on creating functions. So we have a couple of slides on that. And then I have a summary slide about stuff that you shouldn't be doing in while using functions. If you have two identical pieces of code, like here, x equals int input, enter a number for I in range x, print I, and I'm have that replicated here. If you have exactly the same piece of code repeated, not necessarily consecutively, you can have a function that has one of these duplicates inside, just copy and paste, and simply call this function twice to get the effect of this duplication. On the other hand, sometimes what happens is we have similar pieces of code like T1 equals M1 times M1 plus 1 minus N1 times N1 plus 1 divided by 2 and plus N1. Here I have pretty much the same stuff, but then I'm using N1 instead of M1 and M1 instead of N1. That is the only difference, really. Wherever M1 occurs, I have N1, right? And wherever N1 occurs, I have M1. That is the only difference. Otherwise, the two are identical. If that is the case, what you can do is give some name for a function and get these two as parameters, m comma n, and use these parameters for this expression. Now, a summary of common mistakes or sources of confusion sometimes. These are important. That is why I have put this red background. Otherwise, I don't like making things so, what do you call, colorful. But I wanted to convey the point. Do not ever modify a parameter before using the value in it. So within a function, If you have a parameter P, don't go and modify P by reading stuff into it or assigning a value to it before using that value. It is a mistake. It is a design error or it's a bug. If a function returns a value, and if you are not using it, if you're ignoring the return value, if you don't assign it to a variable, or if you don't print it or use it in an expression or a condition, you are possibly making a mistake. Another thing is, if you use the same identifier for functions and variables, it can be very confusing. So for example, if you have a function named f, don't also have a variable named f. It is going to be very confusing to you. Also, whenever you use a function, put parentheses. For example, this is probably not what you want to do. Define a function called f, which returns something. It doesn't really matter what that is. But if you want to print whatever it is returning, don't just put f here, put parentheses after f.